Hello everyone. I'm going to do an example of using the law of cosines to solve a triangle. So if I look at the information I'm given in this triangle ABC, I know a side length, I know an angle, this is the included angle in the middle, and then I know another side length AC over here. So this is the side angle side situation. So because of the way my information is laid out here, I know I can use the law of cosines to start and solve this triangle. So the law of cosines, if I write that down, c squared is equal to a squared plus b squared minus 2ab cosine of c. So the important thing is that the angle here, this angle has to match up with the side length across from that. The one angle that I know, angle C, is the 65, so I can use the law of cosines to solve for this side length that's across from it. A and B are interchangeable. The way that this triangle is labeled, I would say A is 5 here, and then across from B, this would be, lowercase b is 8. So if we plug that all in, so c squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 and the cosine of 65. So we have a pretty long expression here. To make this a little bit easier to work with, let's do a little bit of simplifying. The biggest thing is you just need to be careful and watch your order of operations. So I'm going to start with my two exponents. 5 squared is 25, 8 squared is 64, and then 2 times 5 times 8, let's see, that's going to be 10 times 8, so minus 80 cosine of 65. If I add 25 and 64 together, that's going to be 89. Okay. So a little bit more manageable. Now, the next step is just one of the mistakes that I see quite often is people have a tendency to want to subtract these two numbers. 89 and 80, they do end up really close together, and it seems really simple just to subtract them, but order of operations tells us that we can't do that. This 80 is being multiplied by the cosine of 65, so we would have to calculate that first and then subtract it from 89. I like to just take the square root of both sides, like so. And now that is something that I can type into my calculator to get my value for that side length. So let's see, so we got the square root of 89 minus 80 times the cosine of 65. I'll close my parentheses, and we end up with C is about 7.4. Okay. So now I found my third side length. Now I need to find the measure of these last two angles. After I use the law of cosines once, now because I know the side length, I should be able to use the law of sines to find a missing angle. So we would know here's an angle, the side length across from that, and then I could use the law of sines to find an angle if I know the side across from that one. So let me just write down the law of sines here. So the sine of an angle and the side across from that, we set that equal to the sine of another angle the side across from that one. So we'll use this to find the measure of angle A. The sine of A, the side across from A was 5. Then the sine of 65, and the side across from that we just found was about 7.4. I think the law of sines is a little bit easier to use. So we can multiply both sides by 5 to isolate the sine of A. And then since I'm solving for an angle, we need to do the inverse sine on both sides. So the measure of angle A is going to be the inverse sine of this entire fraction. And let's see what we get for that. So the inverse sine, so I just need to be careful on how I type this in. 5 times the sine of 65, I'm going to close my parentheses there. Divided by 7.4, I'll close my parentheses again. And we end up with about 37.8 degrees. Okay. And now just one more piece of information to find. We have our last angle. Now that I know 2 of the angles, I can find the measure of that third one with the triangle sum theorem. So 180 minus 65 minus 37.8. So then our last angle, the measure of angle B, is about 77.2 degrees. If we take a look at what we ended up with, 5 was our smallest side length, so that means the angle across from that should be the smallest angle, which it ended up being 37.8, so that checks out. Angle B ended up being the biggest angle, so that means the side across from that, this 8, should be the largest side, which it is. So there's an example of using the law of cosines to solve the side angle side situation.